位同学好 dear faculty and the students, let's begin this morning's special seminar. Today our distinguished guest is Professor McBean from University of Western Ontario, Canada. So first of all, on behalf of the entire department, I would like to express our very warm welcome to you. It's a great honor for us that you can visit our university and give a seminar here. And so I will present you a very small gift. So you can use it when you go back.
Oh, that's very nice. That's very nice. Thank you.
Yeah, thank you very much.
Thank you.
In the following, I would like to invite Professor Wang to give us an introduction about Professor McBean.
It's really my pleasure and honor to have this opportunity to introduce you our speaker today. Is Dr. Gordon McBean. Professor McBean got his bachelor degree in physics from the University of British Columbia, and then get a master's degree in McGill University. Then afterwards, go back to the University of British Columbia, get a PhD degree in oceanography in the 1970s. Then after that, he went to the government service in the Atlantic Canada for many years, right? Then he went to go back to the University of British Columbia, become a full professor in that university and serving as a department chair on the atmospheric sciences and also the oceanography, as I understand. Then after 1994, he was dragged to the government service to become the deputy administrator. Deputy Assistant Minister of the Atlantic Canada, supervising the meteorological service， 其实就是气象局长的意思，就是气象，就是环境部里面的气象局长，不是我怕你不知道，不是。So after serving that on the year of 2000, he went back to the Western Ontario University to serving as a professor in the particle science department, and he's now working on teaching the classes environmental policy. But for his career for the past 30 years, actually, Dr. McBean is very active in the international academic field. Especially now, he was the chair of the Canadian Foundation of the Meteorological and Oceanographical Foundation， 就是有点像自然科学基金会的一个主席那是非常重要的一个职位。He was also now planning group chair of the 这是国际科研的一个 planning group the global change research and the disaster related committee group chair. And most importantly, today we are welcoming him on behalf because he was the staff scientific steering committee chair. Probably some of them you didn't know, because the STAR in the international, they have 6 regional offices in the world. And in the Southeast Asia regional office, which is located in our National Central University. So this morning we have the opportunity to take Professor McBean to the South office. It's really a pleasure and honor for us. So it's all and of course, Professor McBean is very, he's very interested in the research from the boundary layer, from the climate to the weather to the science policy connection, weather forecasting. Many aspects of the research, he has all the interest. He also was a fellow of the American Meteorological Society and the Society of the Canadian Oceanographer and the Atmospheric Sciences. So, and he also has another award. So, I think without further ado, I'm going to present you Professor McBean.
I think I'm wired for sound. I'm very pleased to be here. I think it's a special pleasure to have visited the Stark Regional Center. This is I didn't realize that you've never had a scientific committee chairman come here before. But I have to make sure that doesn't continue to be the case too long in the future. I've also good to reacquaint with your colleagues here, KK, who, as he reminded me, we shared a cab in Moscow a few years ago in the wee hours of the morning.
And you paid the pay.
Well, I wasn't excited, but yes. So anyway, I'm very pleased to be here at the National Central University. You also have a colleague here who used to work here, who's a good friend of mine from Canada, originally from here, Professor Henry Cho was a very good colleague of mine. who is now back in Canada. So what I wanted to do was to talk generally, I'm talking more as a policy person. This is not going to go into the details of science, but if you want to talk about that, we can try and do that too. So let me first of all say I'm talking primarily about natural hazards, and so when we start off, we usually try and define a hazard as something that will potentially, physical, environmental phenomena that may cause significant property damage, loss of life, impact on people, and it depends on the vulnerability, let's say the conditions which make people susceptible to being impacted by natural hazards. And when you get a disaster, it is usually because there is, as we say, an intersection of a hazard and a vulnerability. So here in Taiwan, you have many hazards. You have typhoons, you have earthquakes. You also have certain systems that are more vulnerable than others, and the disasters happen when you get the two come together. And so as a policy point of view, we can worry about the hazards and try and, in the case of climate change, understand how they will change with time, but we also could worry about vulnerability. So I'll try and talk about those two kind of things. A disaster is just defined this way. It's basically when a community is overwhelmed. So we have a community that is unable to, let's say, defend and cope with its own resources. And the reason why I define that is we see the number of these disasters around the world are going up very dramatically. The numbers across the top are the number per year averaged over a decade. So back in the 1950s, we had 60-some per year. Since 2000, we've been having more than one disaster per day around the world. And the big question is why? The economic costs are going up. The Hurricane Katrina cost somewhere in the $150 billion range. The Kobe earthquake was over $100 billion. We've had many disasters in the 10s and 20s, $30 billion range. And we hear about the major ones, the hurricanes, or the typhoons, the earthquakes, the tsunamis. But when you look at the statistics, floods, storms, and droughts are causing over 75% of the hazards of the disasters around the world. So although the earthquakes, when they happen, are really horrific, you get huge loss of life. If you're just counting number of events, the vast majority of them are actually floods, storms, and droughts, and often interlinked. I mean, it's a storm like a typhoon that creates a flood, and it's rather arbitrary whether you call it a flood or a storm, but nonetheless, those weather-related ones are a major part of this. There's also things like landslides or debris flows that are also being part of that hydrometeorological issue. If you look just in the last couple of years, the numbers are still pretty much the same. Floods are the biggest one, windstorms, earthquakes, extreme temperatures, very hot conditions, or in some cases very cold conditions, floods and slides, etc. The issue that's particularly important here, I guess, is that if you look at the number of people who are killed by natural disasters, it is predominantly in Asia, in the very large populated areas most often, but nonetheless, in the average from 2000 to 2005, 84% of the deaths around the world due to disasters of this type were in Asia. So one of the questions we ask about is why is the increasing number of trends? Well, first of all, we have more people. We have great concentrations of people in communities. We have more poverty, and it is usually the poorest people who are impacted by natural hazards. It is either the very young, the very old, or generally poorer people who don't have the capacity, the information, or even the possibility to do much about the event that is happening. We also have more structure, more buildings. So when you have more buildings, more bridges, more infrastructure when there's a storm and the costs, then these result in the costs, and they often, as we were driving down here this morning, I saw all your freeways, and I don't know what happens with earthquakes here, but I was in Kobe, Japan, just after their earthquake, and saw the freeways, and also in the United States, the freeways collapsing. And those kind of structures, unfortunately, are often in countries around the world aging. They maybe not have been designed as well as they could. There's also the choices people make or the necessities. In most cities around the world, the poor people are clustered along the coast zones, along the river banks, or along the slopes of hillsides, because those are the places where they can afford to live, and that puts them more vulnerable. And then we have human intervention in the environment. We're changing landscapes, deforestation, mangroves, etc. And we're also changing the climate. So I want to talk a bit about climate change as an issue in this context. So this is from the Intergovernmental Panel on Climate Change. We've seen how the temperatures of the planet are warming, but in the last 25 years, we are warming now at a rate of about 0.18 degrees Celsius per decade. So, whereas the average over the last 100 years was about half as much. So this acceleration. We're also seeing, as the IPCC report said, the climate system warming is unequivocal. We see the warming in the global air temperatures, water temperatures, melting of snow and ice, rising sea levels, etc. So the evidence of a warming climate, I think, is, in my view, indisputable anymore. There still may be a few people. We have some in Canada who dispute climate change, but we probably have some here too. But I think the evidence is very strong. I guess the question then is, we use that kind of information to project to the future. We can look at, from the IPCC report again, at the next 100 years, various emission scenarios. I guess the first thing to note is that we, as I said, we've been warming at a rate of 0.18 degrees C for the last 25 years, and we'll warm at a rate that is probably about the same or slightly larger in here for the next 25, 30 years. The difference between the emission scenarios really doesn't make much difference until you get out sort of 50 years and beyond. I should explain, this one is a hypothetical scenario. Anyone guess what that is? That's when they said, well, let's suppose that humans were to stop tomorrow emitting any greenhouse gas. Now, that's not likely going to happen. But supposing that happens, then what this is saying, though, scientifically, is that we have already built in a rate of warming because we have already so much additional CO2 in the atmospheric system. We have built up an inertia of it, and the warming rate for the next 100 years would be even in this hypothetical situation about 0.1 degrees Celsius. In reality, the science is saying it's going to be about 0.2, but then as we go to the end of the century, if we continue to increase the amount of emissions of CO2 and other greenhouse gases, we could have a rate as high as 0.8 by the end of the century, or if we were very optimistic, we could lower it down to about 0.15. I think it's useful to look at it that way, because even though this is not what the, let's say, environmental groups want to happen, this is, I think, the unfortunate reality of our climate system, is that we have built into, because of past activities, mainly in developed countries, United States, Europe, Canada, Japan, because not the emissions you make this year that matter, it's the emissions you've made over the last roughly 100 years. Because that's how long CO2 stays in the atmosphere. I usually say to my students, if you think back to your great-grandfather, who most of them have never met, what your great-grandfather did in terms of stoking up the fire, driving an automobile, or if they had one in those days, that CO2 is probably still in the atmosphere. It's about a 100-year lifetime. Is that right, Mike? All right. I have to check when I got such illustrious colleagues here in the class. The other thing important scientifically is that there is still a significant scientific uncertainty in this. Scientific uncertainty does not take us down to zero change, which is here, but for, say, this scenario, where the global mean temperature change by the end of the century is 1.8 degrees C, it could be as low as 1.5, it could be as much as about, well, almost 3. So we have this 1/2 to maybe a little bit less than a degree Celsius uncertainty, and that's an important scientific issue that the scientific community needs to work on to reduce that uncertainty by better understanding the physics, chemistry, biology of climate systems, producing better prediction models. We can also say, though, that our impact, our being the global community, if we take the uncertainty, it could be as little as 1 degree Celsius warming, but it could be as much as 5 or 6 degrees Celsius warming. And 5 or 6 degrees Celsius warming is about the same between the present conditions and an ice age. But the rate of change here is that kind of warming in 100 years as opposed to over roughly 10,000 years or more. So anyway, keeping that in mind, we try and look at how can we respond to climate change. We have a simple cycle, socioeconomic development leading to emissions, concentrations, climate change, impacts, and so on. And we usually think of it as responding in 2 ways. One is emission reductions, or avoiding the unmanageable in some contexts, which means you try and change your socioeconomic development pattern to reduce the emissions so you have less climatic change. And that's what the meetings in Bali that are starting in a week or so, that is the Kyoto Protocol. Everything is focused on reducing emissions, and that's important. The other side of the coin, though, if you recognize the science, which is saying the climate is changing anyway, and we're going to have a climate change built in for the next few decades, is we need to have adaptation strategies. And that's where there's a huge role for science to figure out what is first of all, the details of that change and how can we adapt to it. Reducing emissions is the climate convention, and one of the interesting parts about the climate convention is it says the objective is the stabilization of the atmospheric concentration of greenhouse gases to prevent dangerous anthropogenic interference with the climate system. And the question we've always asked scientifically again and put as a policy question, what is dangerous? And for example, this is some work done in Europe looking at when does it become dangerous in terms of for water systems, and as it gets redder and redder, the assumption is it is more dangerous. So they basically tried to assess the impacts of climate change, and these are attempts to estimate the global mean temperature change with respect to pre-industrial conditions. So for water, eco, health, coastal zones, tourism, etc. And you can see, generally speaking, they start to get pretty red by the time you get to 2 degrees Celsius. And it was on that basis the European Union and others have said 2 degrees Celsius corresponds to dangerous climatic interference. I don't know whether you've done analysis here or not. We haven't been done yet. So anyway, as I just said, people have talked about somewhere in the 2.5 degrees Celsius range as being dangerous. And remember, we're not measuring it with respect to this point, we're measuring back from here. So 1, 2, 3 degrees Celsius warming, even this most optimistic scenario says we will reach 2 degrees C warming before the end of the century. So that really makes us quite concerned, and I think we need to scientifically better understand, first of all, are these relationships right? What is going to happen as we go towards 2 degrees Celsius warming or not? So the other thing is, though, while we're working on the emission reduction strategies, we need an adaptation strategy. And the reality is, of course, that none of us live at the global mean. When we talk about 2 degrees Celsius warming, we're talking about a global mean temperature change. In this scenario, the particular scenario is one where the global mean temperature warmed by 2.8 degrees Celsius. In my part of Canada, that means we warm at about 3.5 degrees Celsius. The Canadian Arctic and other Arctic regions will warm by more than twice as much. Here in Taiwan, you're probably a little bit warmer than the global average, but not much, because you're an oceanic country, but you're north of the equator. And so you need to understand how this global number converts down into not only country numbers, but down into the details of the region. The other thing that we worry about, and this is where, as a natural hazards program, we're particularly concerned, is on the whole issue of the extreme events. It's not the average temperature that mostly matters, it's the particular extremes with respect to that. And if we just remember our basic science, that we have perhaps a quasi-Gaussian distribution like this, and if we have an event that happens once every 40 years based on some absolute temperature or wind speed or rainfall amount, and if we shift the mean of that and still keep our reference point, the 1 in 40-year event becomes a 1 in 6-year event. So when you're designing your storm, your river flow systems for river banks, the 1 in 40-year rain event that used to happen with the new climate and some kind of shift may be happening 1 every 6 years. And that makes a difference in your design criteria, it makes a difference in the way in which you think about it from a hazards point of view. As I said, most of our infrastructure is designed for looking at the past as opposed to looking to the future. And what are some of the projections? Well, this is the projections for hot days. We look here around the world, this is the increasing, as the colors go up in here, what you're basically saying is you're going to be getting a higher percentage of very hot days. Days, I don't know what a hot day here is, but typically we'd say a hot day is over 30 degrees Celsius. So that as you move to the future, we will see in these parts of the world, and Taiwan is, well, your country's not very big on this kind of map, so that it gets sort of lost in the grid scale of things. But nonetheless, generally speaking, this part of the world through here, as well as Australia, is in areas where we will see a much increased number of very hot days. So we'll have more warm spells. We need to then worry about design of structures, cities, not have air conditioning systems that rely on fossil fuel energy, because that will then feed back into making the greenhouse gas and the local air pollution problems more. We also need to recognize that it is often on the hot days where we get smog conditions that are particularly bad, stable air conditions, buildup of smog. And so you get these compounded things of more hot days and probably more air polluted days. And so the need for health alerts and responses, medical advice systems as to how you respond to those kind of conditions. Precipitation is perhaps most of interest to us. This is the changes in patterns for the June, July, August versus December, January, February. Here we have in the December, January, February, the winter time, the expectation is in the brown here up through here is a reduction in wintertime precipitation. In the summer, the precipitation will probably be more or less similar to what it is now in average amounts. But again, the extremes are going up. More heavy precipitation events is very likely. Less so right here in the Taiwan area, but certainly in areas around it, in Indonesia, parts of China, Japan. The changes are up into very significant increases in the number of heavy rainfall events. So we need to worry again about flash flood control, design of structures, water supply systems, sewer systems, agricultural systems. How will that changing rainfall situation affect them? And I should get a picture of an Asian typhoon, but this is tragedy of Hurricane Katrina. And what we see is that the number of intense cyclones is increasing. This is for the Western Pacific. These are Category 4 and 5 cyclones or hurricanes. And according to these numbers, had roughly 85 in the period 1975 to 89. In the period 1990 to 2004, the number had gone up to 116. We are seeing increase in the number of typhoons, the number of hurricanes in the North Atlantic, which is somewhere around there. And the prediction of the IPCC was that future tropical cyclones will become more intense with higher peak wind speeds and more heavy precipitation associated with the ongoing increases in tropical and subtropical sea surface temperatures. So as our temperatures of the oceans are warming up, cyclones, even though the expectation is we won't have more of them in total, the percentage of the cyclones that will happen, or the typhoons, will be more, let's say, more intense ones within that categorization. Another big concern is sea level rise. This is the last 150 years or so of sea level. The rate again of sea level rise is also going up. We're now, for the last roughly 20 years, the rate of sea level rise is at about 3.1 millimeters per year. Not quite double, but almost double what it was averaged over the last 50 years. The Intergovernmental Panel on Climate Change's latest report was, we think, pretty conservative on sea level rise, and mainly because they didn't quite know how to handle these things. The major ice sheets of Greenland in particular had very complex, let's say, dynamics, thermodynamics, and in the end, I gather the committee just decided they didn't know quite how to predict it, so they left it out. So the projections they have in the Intergovernmental Panel on Climate Change reports are for sea level rise just due to expansion of the ocean due to the warming water expanding. But it is certainly a concern that as Greenland melts, and it is now starting to melt at a much faster rate than before, that extra water being added to the oceans will cause the sea levels to rise more dramatically in the future than they have in the past. So we do need to improve our projections and confidence in these sea level rise predictions, because I was looking at in our meetings we've been having the last few days in Taipei, there were people showing maps of, as you don't, if you raise the sea level not very much, the impacts on the areas around Taipei. My sense is you're pretty much above ground here, but I flew into Bangkok last week, and I'd never flown in Bangkok airport before, but as we came in from the ocean, we passed over kilometers of land that was within basically at sea level. All the fields, the small villages before you got to the airport, and those places are very much under jeopardy with very small amounts of sea level rise to put that part of the world in problem. So, I guess one of the things we need to do is recognize these things, and we need to focus on disaster risk reduction and human vulnerability. And I think this is a challenge for the research community as well as the government. And just to mention a couple of things, the whole question of sustainable development. This is the usual definition of sustainable development, the development to ensure it meets the needs of the present without compromising the ability of the future generations to meet their needs. And what that really means is looking to the future. And we need a better capacity scientifically to be able to project ahead and say, okay, well, if we're talking about sustainable development, what does that mean? What is the situation going to be like in 2050? What's going to be like in 2060, even 2030? And we also recognize that natural hazards, even if we don't know exactly what they are, is going to be part of that future. So So a prediction capacity is needed. Again, it's a scientific question, at least initially. We'll come back to that in a minute. The World Conference on Disaster Reduction in Kobe also talked about the need for what they call resilience of communities and nations, but also early warning systems, early warnings of typhoons, early warnings of floods, early warnings of earthquakes, to the extent that's scientifically possible, etc. And the importance of an integrated, multi-hazard, and multi-sectoral approaches. And we needed to bring this together. I mean, the sense of all of these hazards happening. The Kyoto Framework for Action, which came out of the Kobe conference, has in it a statement that the starting point for reducing disaster risk is knowledge of the hazards, the physical, socio-economic, and environmental vulnerabilities, and the ways in which hazards and vulnerability are changing in the short and long term. Again, very much a role for the scientific community in terms of saying what are the hazards now, and particularly how are they going to change in the future, and how will societies also change. So we can look at prediction in a simple way. We have a present, now, and we predict the hazard. But what we also need to be able to do is predict that given that hazard, what will be the impacts. And we need to worry about response strategies that both try and reduce the impacts and where it is possible, change vulnerability or change the hazards. And so, if we look at it from a natural science point of view, our focus is on predicting from the now, predicting the hazard. As I was talking with somebody a bit earlier, we need to be able to know now how will the detailed characteristics of cyclones, typhoons change over this part of the world in 10 years, 20 years, 30 years as an input for the planning processes, the building of resilience. The prediction, I used to be the head of the Canadian Weather Service, so one of my things I used to always harp on was we need to be able to predict for today, tomorrow, next season, next decade as a continuum, that we don't have weather forecasts going out and then some other time a climate forecast and that people don't connect between them. That there's the seasonal predictions and the longer term predictions that should be seen as a continuum of things. We should be looking at how they occur naturally and how they respond to, in the case of climate change, human interventions. So going back to this diagram again, we can also look at how the hazards, given that we can make some predictions of them, how do we predict the impacts? And that's where we need to work better with the social economic communities, the health communities, and the others. So it's a combined social engineering, health, research activity of connecting predicted hazards with predicted impacts. And also to understand how we can change vulnerability, gain social engineering, those kinds of things in terms of research activities. So we have been putting together an international framework. This exists. We're trying to improve the communications and public education to accelerate adaptation, mitigation studies, multi-hazard socioeconomic assessments, and we need to work about building communities that are not only greenhouse gas friendly, but also climate resilient. Working on these things two together as opposed to relatively separate. So, as it was said in the beginning, I chair a program for the International Council for Science, which is a non-governmental science organization that brings together unions of scientists in math, physics, chemistry, biology, geology, and all those fields. There's, I think, 28 or 30 unions of scientists, as they call them. And they put together programs like the IGBP, that is Youth on, the World Climate Research Program, and we're now talking about a new natural hazards program. And we've come up with, and you're one of the first people to see this since we only agreed a week or so ago on the new name, and we're calling it Integrated Research on Disaster Risk. would be a research program on natural and human-induced environmental hazards. We would take an integrated approach of research on disaster risk through the combination of natural sciences, so people in atmospheric science, oceanography, geology, hydrology, health, engineering, and social sciences, including socioeconomic sciences, in a combined way to look at the issues of disaster risk. As a legacy of the program, international programs always have to have a legacy. You have to say, well, what are you going to do if you're successful? That's what we're going to do. We're going to make it less likely that disasters kill people. The scope of the program, this gets into some of the jargon of disaster management. We want to focus, well, when you talk about a disaster, there's usually several things you can do. Normally what we do now is we wait for the disaster to happen. You know, we don't wait deliberately, but it happens and we respond and we recover. So response is the actions taken to go in and save people right in the time, and recover is then to try and rebuild the community. And this tends to be a fairly, it's a very important community, obviously of technical people, of medical people and others, but there are different, let's say they work in different ways than typically the atmospheric natural sciences community. So we want to focus on what is called mitigation preparedness. Mitigation in this context is the actions taken before or after a hazard event to reduce the impacts on people, and preparedness is, like say, getting ready so that it does happen. And both of these are areas where atmospheric science, oceanographic hydrology, the sense of predicting there's a hazard either going to happen, there's increased risk of it, how do we address it. And so we're going to, this research program will focus on research activities in what we call prevention, preventing natural hazards becoming disasters. It will cover the whole gamut of hydrometeorological and geophysical trigger events, and particularly also work on the issues of where humans, by choice or otherwise, are making ourselves more vulnerable. As we were discussing on the drive down today, when people choose to build I think it was a nice little holiday retreat in a historic mountain area, and in doing so they drive a road in, everyone wants to drive to this picturesque place, and by putting the roads in, they make it more likely that when a debris flow happens, a heavy rain event, it becomes even worse, the road is wiped out, and then people complain, they want it rebuilt. And maybe a better solution is just not to be there at all, or at least to design and develop it in a different way. And I think there's a role in trying, for us as scientists, to try and do that. But we have this proposed natural hazards program. I'll just very quickly say these are the research objectives as presently defined. Characterization of hazards, vulnerability, and risk, identifying hazards, forecasting hazards, and trying to integrate a dynamic modeling of risk, bringing together not only the natural sciences, but the social, engineering, other sciences, and really able to say, okay, well, the risk of these kind of things is now, as society changes, as the hazards change, how will the risk change in the future? We identified that there are big issues on understanding complex decision-making, as we talked about in the little, I mentioned a minute ago in this little question of the resort in the mountainside. Why did people choose they want to do it that way? Well, in some cases you have to have a process by which you tell them you can't do it, and others you try and convince them by good logic you can't do it. But this whole question of how people make decisions is a big issue in the social sciences. Psychologists write books on this, perception of risk. I was reading part of one yesterday. And when you ask people to make the choice, an example I remember reading was if you say, okay, you have the option of losing $100, but the risk is only 1 in 10 that you'll actually do it, or just paying $10 to make sure you don't lose it. Guaranteed you're going to lose it. And you ask people, what will they do? Well, it turns out most people will actually make the choice of taking the risk of losing $100 in hopes they're the 9 people out of 10 who don't get the $100 and don't actually lose anything. And how do you understand how people perceive risk when we make our weather forecasts? How do people understand the risk of those? We still use the same term, at least in Canada. The forecasts look the same now as they've always had. Chance of showers tomorrow, 50% chance of rain. As the standard Canadian says, does that mean I wear one rubber boot and not the other, or whatever? We've never really understood how people understand our forecasts. And I've been doing some work with sociologists on this, and it's amazing how people don't understand whether, in our case, we use tornadoes as a big issue in hazards. We have a watch and a warning. And we asked Canadians, how many people know what a watch and warning is? And none of them did. Almost none. So those are kind of issues that, as natural scientists, I never used to think about now, but as a more of a policy person, I think about. So we're also going to look at into more vulnerability assessment, cases where we've actually seen success stories, and there are success stories where people, often communities, have worked together to reduce their vulnerability so that when the hazardous event happened, there were less impact. There are also cases where people made all the wrong choices. And so we want to look through those as case studies, try and understand and hopefully build a textbook of good cases and some not so good cases. It's going to be very important that there be a capacity building activity part of this. And we're hoping to use the START activities that already exist here. And I should say right now that the office here in your university is, we think, is the sort of the keystone, one of our really good places where we say that's really, really good work being done there. So thank you for that. But we'll need to build, link the capacity building activities in disaster reduction with the capacity building activities on environmental work, because they're very common and overlap, and let's not try and separate them. We also have to worry about the whole issue of data management and monitoring. This is, again, common problems with atmosphere, ocean, arbiters, community. So, where are we going? Well, we say now to implementation. We have two sponsors, the International Council for Science and the International Social Science Council. They're both non-governmental organizations. They will bring together a cadre of people. We expect that in due course the United Nations Environmental, Scientific and Cultural Organization, by the name of UNESCO, and the World Meteorological Organization will be at least collaborators, partners, something. We don't know quite what the terminology will be, but we're meeting with them. The International Strategy for Disaster Reduction is the United Nations main program, which is under the Office of Humanitarian Affairs. They've endorsed us. They say, yes, we want this to happen, get going. And we have a planning office, or we'll go ahead momentarily. It's very important to involve the regional programs. There is the International Council for Science has established a regional office for Asia and the Pacific. A group of us were in Thailand last week, including Professor Liu, formerly the president of this university, I believe, and others, to discuss what is called an Asia-Pacific Strategic Planning Group on Hazards and Disasters, which has this terrible, unpronounceable acronym. Strap grab or something like that. Anyway, whatever it is. So there will be regional programs, and we want to link these regional programs on hazards, of course, with the regional programs under START and IGBP and WCRP, etc. We'll have a whole, I think some of you here are working through the DOT star, which is a part, at least connected to FORPEX, which is, and don't ask me what FORPEX stands for, but it's a storm study experiment under the World Weather Research Program. We've been just so that we will use that existing research program in a way that actually builds on it, works together, also the WCRP, etc. So we expect the program will be underway next year. I'm not sure what underway means, but it will be officially inaugurated, we'll have it in place, and we'll then start building the projects, the research projects, making the alliances, etc. So with that, I'd like to thank you and be quite happy to answer and discuss any questions, comments,
interesting talk. Yeah. So the floor is open for discussion and any comments of the audience.
Thank you very much, Professor McBean, for very valuable presentations. I have two questions, so I'd like to have your comments. First is you say for all of people killed by natural disasters, about 74 to 84% are in Asia. So I would like to know how many percentage of those natural disasters are linked to the anthropogenic conditions. You have a figure?
Probably not many of them. We could go back to that. I would when we look at things like fatalities, they are, you get big events. I mean, of course, like the earthquakes in Pakistan, the tsunami in the Indian Ocean, which had nothing particular to do with, well, they had nothing to do with greenhouse gas anthropogenic effects. They have effects due to other human activities, probably. But if you go into some of the typhoons, you could say, well, yes, maybe they are related. I think as a scientist, I wouldn't claim that those numbers, you can't say that typhoon was stronger because of greenhouse warming. What you can hopefully say is that the statistical ensemble has changed in a way. But I would say most of the deaths are probably not due to climate change. But there's a climate factor. Anyway.
Right. Thank you very much. So this leads me to the second question. In your presentation, you say not the emissions that you emitted today that matters, but the emissions that you emitted in the past 100 years matters. So we know very well for the past 100 years, not many countries in the world who are capable in emitting greenhouse gases. Very few, such as North American country, Western Europe, and Japan. So now you say it is a global community who has to take the responsibility to help the earth. So this is always my wonder. Especially this year, we know Al Gore winning the Nobel Prize. So that to me is outrageous. So quite unbelievable. So I'd like to hear your comments on this. Say, what will we take on this event? Say, what should we look to the future and how? I don't know how to say, but each time when I hear this kind of so I can't help but wonder how is the future we should look when we think back.
Well, of course, Al Gore shared the Nobel Prize with me. I'm a member of the IPCC. We won half of it, and actually, just so you know, it's interesting. I give lots of public talks in Canada, and I was talking to an environmental group, and I say, how many people know who won the Nobel Peace Prize? And they all said Al Gore. And I said, did anyone else win it? And they said, I think so. I said, are you sure? And they finally, somebody said, some kind of funny committee. So anyway, I'm a member of that funny committee. That's just an aside. But no, I think that the point, which and I'm not exactly sure I think the point is that if you look at the amount of greenhouse gas in the atmosphere, I don't have that diagram in this presentation, but we're now at 381 parts per million. We just hit the big number, the biggest number ever. Well, not ever, but in the last million years. And about 80% of that increase from 280 to 380 is due to what you would call the developed countries, of which the United States, Canada, Europe, and are basically the contributors. And what is tragic is that even though these numbers are not necessarily due to climate change, as we look to the future, it is an event brought on by the developed countries. And when I meet with my government, I say, we need to take a role in this because we are a major cause of what's happening now. I think it is unacceptable that governments like mine and the United States, how many people know whose government has been the least affected by climate change in probably the world? Canada. No, Canadian emissions, we've signed and ratified Kyoto. And our emissions have gone up double what the U.S. has gone up in percentage. And that, to me as a Canadian, that's unacceptable. And I find that very sad as a Canadian to say that our emissions have gone up at a rate almost twice as fast as the U.S. ones, even though they did not ratify Kyoto. We ratified it and did nothing. And I've said that to my ministers. But they don't pay attention to me, I'm just a minor scientist. So, and your point is, when I say global community, we do have to work together globally, we need the right balance. And I think that, quite frankly, China, the one which is capital of Beijing, needs to start recognizing that even though they have not created the problem we've got, they have to be part of the long-term solution. And we need to work together in a global way.
I'm sorry, just make a short comment. Actually, I completely understand this is a global issue. It needs to be tackled by everyone in the world. But I can't help. I wonder who give us this warning word.
No, the developed countries gave the warning world.
Okay, thank you. Thanks.
There's no question about that. No, and it's, on a per capita basis, as we were discussing, and I think in the car this morning as we were coming down here, the emissions of the use of energy per unit of GDP in the U.S. and Canada is about 20 or 18, somewhere in there. Greenhouse gas emissions in tons per unit of GDP. In Canada is about 18, U.S. is about the same. Japan is about half that, 8 or 9. UK, Germany are a little bit about the same. China is India, well, India is 1. And most Asian countries. So on a per capita basis, yes. I think you and I agree.
Thanks.
I also have 2 questions. One is, do you have any comment on the change of guard in Australia?
Pardon?
Change of guard in Australia. Do you think that will bring some new trend in politics in the Western world?
Yeah, I think it is unrealistic to think that they're actually going to do Kyoto, but if they ratify Kyoto, and it depends on, as you may have noticed, if you were watching carefully, I did not, because I don't think I mentioned the Kyoto Protocol in this presentation. I prefer to talk about the Climate Convention. The Climate Convention, which has that preventing dangerous anthropogenic interference with the climate system. That was signed and ratified by basically every country in the world, including the United States and Australia. As I occasionally point out in less polite audiences, it was signed and ratified by George Bush the Smart. And it was in fact in my country. We have a conservative government, which we have not had since 1993, but it was the previous conservative government we had that signed and ratified the Climate Convention. It was the liberal government in between that signed and ratified Kyoto and didn't do anything about it. So anyway, I think it's encouraging a little bit that the new Australian Prime Minister, because the governments like mine and Australia and the United States that have been, let's say, not doing things, have often sort of allied themselves with the Australians in the past, and that's not going to be possible now. That's good. So, I'm not a total pessimist, but I'm not really very optimistic right now either.
Well, then, the second question is probably we are on the optimistic side is how to engage politicians. They are by definition are all short-term people.
Yeah.
What's your strategy to approach those people and how to convince them?
Well, if you read the Canadian National newspaper on January something or other this year, you would have seen a picture of me and my two grandchildren. Because a newspaper reporter asked me the same question. And I had the opportunity, not with the present government, but the previous government, to brief the federal cabinet in the Torah at a retreat. They all went out to the countryside retreat and they asked me to come up. Interestingly, they phoned me on Wednesday and said, we think that the cabinet actually needs to have a science briefing on climate change. Will you come up and do it? I said, sure. How much time do I get? 15 minutes. And no PowerPoints eventually. So anyway, I did it. And they asked, one of the ministers, being fairly frank, said the same thing you did. What's in it for us between now and the next election? Or words to that effect. And I said, he said, why would we do this? And I said, you do it for your grandchildren. That's why this reporter, when I told her that, she had to get a picture of me and my grandchildren. And I think that's all that you have to argue, is that as a politician, even though you may think your most important objective is getting re-elected, that you need to have a sense of leadership and looking to the future. And the future has to go out through to our grandchildren and our great-grandchildren, depending. I mean, I have two grandchildren now, and I worry about them. And so we have to try and get that sense that it can't all be now focused. And we as individuals have to think about it too. We can't just focus our own lives on now or the next week. We've got to think beyond the longer term.
That's a very good answer. We go back to the fundamental definition of the sustainable development. Right? You know, the next generation, you have to care about the next generation. You think about it. Okay, any more comments, any questions?
I'm curious about how different countries respond to the climate change. For example, Australia, I look at your global warming maps. Australia seems to have quite substantial warming. And also, I think there's a very severe drought, very persistent drought going on in Australia. So I think maybe Australia will be very, very keen in how climate change affect the environment. Okay. But how about Canada? It seems that the warming will do very good to Canada. Okay, for example, China. We know that in northern China is having persistent drought for 20, 30 years. So, and whether this is natural or climate change anthropogenic, I think China, of course, is very concerned about the water resources. So how about Canada?
Well, this is the present Prime Minister of Canada's riding is right there, in the middle of what will be a very drought-stricken. It's already we are seeing major droughts on the Canadian terrace. It's interesting. I mean, what drives politicians is people. The present government of Canada, when elected in January 2006, did not include the word climate change in its platform. It showed no interest in it. It said it was a non-issue. 6 months ago, over the last year, we have had a series of events. Another drought on the prairies. We've had severe fires in the interior of British Columbia. We've had heavy rain events in Vancouver such that it washed the reflow into the water systems and they had to boil water for a month in Vancouver. We've had storms. We had a $500 million rain event that caused damage in Toronto. And what the result is that when you ask Canadians now what is the most important single issue, here's 10 issues, economy, health, etc., what is the most important single issue, 30% of them say it's environment. And the government is now scrambling to respond to that public pressure. And I think that's where we as individuals and scientists can also play a role. I don't talk to the politicians anymore because, first of all, they don't listen to me. But I do talk to the media. I exchanged 2 email messages this morning before I came to this meeting with a reporter for our national press who emails me all the time. Gordon, can you help me understand this question? It was to do with the ice in the Arctic. And so I would hesitate. I answer right away. And I bet them to try and convey the message to the people. And I think that's important for all of you. You can do it from your local community newspaper, your school newspapers, whatever. Fourth slide? Okay. Which one was the fourth slide? This one?
For each bar, like with the logo, the hurricane, is that the total amount for the?
Oh, those, yeah, no, these numbers here are just symbolic. They're not actually, I did not try and put them in the right place, because I don't know exactly the numbers.
Yeah, and so my next question is for example, for this three kind of is there any possibility that you double count the digester because they might come together?
Well, these are dollar amounts in this diagram. These are money. And what's shown here, and these came from the insurance companies. This is this comes off unit reinsurance. And what this is, it shows, if you can see the difference, there's a light blue at the bottom. That's what the insurance companies paid. And the dark blue is what they estimated the total cost was. So that's an estimate. But there may be some discounting of this, but you can get all of this information on there's a website which is underneath this piece of the thing. But anyway, McBean-The website. There are various websites that tabulate these things.
The cost from each kind of
I'm not sure, but I mean, each event of the whatever number, out here you can say there was 1,444 hydrometeorological events. They have an index on this website you can go through, and for each one of them they say their estimate, how many people died, what was the economic cost, and you can add them all up. It's a center in Belgium that does all of
The
this.
sum of the total.
Yeah, and they just, yeah. This is on your computer, so if anyone wants the slides, go ahead and have them. There's no proprietary rights.
On the project you are talking about, so I'm thinking about the implementation of the project says that integrate research on disaster risk. Are you going to go for a national committee as like the way they are more for ITPP and IHPP? So what have you in mind?
Probably that's the way we'll go. We haven't started that process yet, but we will. The expectation is that sometime in 2008, hopefully early, there will be appointment of an international committee like there is for IGBP and for SART. And that committee would then, and through various channels, we would talk to governments and say, we think, we'd like you to use it. We think a national committee approach is the right way of doing it. That kind of thing.
Yeah, because from my personal thinking, I think the project's coming in the right time, in the right, it's a really good timing because for the first 20 years of the IGBP, IHPP has was a very basic scientific research, and then go to ESSP for the water resources and the energy for agriculture. Now coming to the globally to talk about on the GCR problem related with the health and disasters, and so it comes very good timing. It seems to me.
Yeah, well, it's tragically good timing because we're getting out of these events. I mean, but like I said, I'm only concerned that we take so long to get it going. The process of international politics and science politics.
We are going to get Mr. McBean-The next schedule, so I can only allow one last question. Okay, please.
I tend to understand there are pages about the hurricane numbers, hurricane risk number. You can go to that page. And I want to know what defines the South India. And the second question is, what reason the increase rates is bigger than other regions?
know exactly. Part of this is some work done by Professors Webster, Curry, Kerry, Manuel. This is mainly, Kerry's work was mainly, and what they've done with this, as I understand it, this is not my work, is they have gone through all of the satellite imagery and used satellite imagery to say when you can, by estimating the size of the vortex and the appearance of it, so that this is the number of cyclones or typhoons or whatever that occurred in that basin. They didn't necessarily ever hit land, which is normally when you talk about hurricanes, people talk about the number that hit certain countries. This is the number they looked at and found over the ocean. Yes. So South India is south of the equator in the Indian Ocean sector. But you better look at the original papers on this one.
All right, yeah, I think it's almost on because we're going to take we're going to meet to another next schedule at 11:20, so we have 10 minutes to walk. So let's thank Professor McBean again. Thanks.
Thank you very much for your coming and your questions.